Hello everyone, welcome back. Let's try to understand what we are going to learn as part of day 3. We are going to learn what is Git and why Git is popular. And we will also talk about how Git is different than other version control system out there in the market. And we will also talk about what is Git workflow and commonly used Git commands. And we will go ahead and set up a Java project in GitHub. If you look at the CI/CD process flow diagram, so this is what we are trying to accomplish, right? So this is a CI/CD process flow diagram, which we have been, referring from day 1. So if you remember, we have already configured Jenkins and Tomcat. And the next step would be we need to go ahead and then configure a Java project in GitHub repository, right? So that we can start our CI/CD implementation. So that is exactly what we are going to do as part of day 3. So the way we are going to implement that is we are going to leverage our Jenkins EC2 instance, and we will go ahead and then create SSH keys, and then we will upload the public key from Jenkins EC2 instance into a GitHub, and we will create a Java project using Maven, and we will go ahead and then perform some Git commands in order to push the Java project into a GitHub. So once we have this project configured, and we will go ahead and then implement CI and CD maybe in day 4. All right, so let's get started, guys. So let's try to understand what is Git and why Git is popular. I understand most of you all familiar with Git, okay, but let's try to quickly cover this, right? So Git is fully distributed. Okay, I do have a beautiful slide, so we'll talk about why it is fully distributed. And then using Git, you have so many options when it comes to branching, right? So you can create a feature branch, right? You can work on your user stories in a feature branch locally, and then you can create a pull request, and then you can have some of your team members review your code changes, and then once they approve, your PR can be merged with the main code base, right? So you have so many options when it comes to Git. And then obviously, right, so Git is also promoting collaboration. So like I said, you can create various branches, and then you can collaborate well within other team members. And Git is also really super fast with the efficiency. Let's say you are a developer, you're working with Git. The way you're going to start working on is you're going to perform clone that's going to download entire repository in your local machine, right? So it would create a local repository, right? So you can start working on your code changes in your local repository. And then once your code is ready, and then you can push your code changes from local repo into remote repo. And then Git is also supporting, non-linear development, right? So like we discussed, you can create various branches, you can work independently, right? So these are all some of the reasons why, Git is really popular. So now let's try to understand a typical centralized version control system. For example, if you take SVN or if you take TFEC, they are all purely based on centralized version control system. So what is the major drawback of this particular model? So as you can see here, central server is going to have all your version, right? Let's say you are a developer, you want to work on a code changes. So you're not going to clone the entire repository, right? There is no cloning concept when it comes to, a centralized version control system. You're going to check out the latest copy, right? And then you're going to work on your code changes. And then when you commit, it would directly go into the central VCS server. So you cannot work offline. So let's say if the central VCS server is down, you would not be able to make, you would not be able to commit your code changes. So you have a network dependency. So that's the major drawback of centralized version control system. But when it comes to Git, this is purely based on distributed model. So as you can see in this diagram, not only the remote server would have all the history, even let's say a developer wants to work on, he is going to do a cloning. So when you do a clone, all the history will be copied in his local machine, right? It is going to create a local repository, and then developer can work on code changes locally, right? He can commit all the code changes locally. And then once he is ready, and then he can push his code changes into a remote repository, right? So this is fully distributed model. So that's the reason why, guys, many companies have moved on from centralized version control system into distributed version control system. And then again, this is another view, right? So this is a traditional, which is nothing but centralized version control system model, right? Where you have a repo only in the remote server. And then these are all individual workstations, right? And then when it comes to Git, like I said, this is fully distributed. Not only you have repo, but repo also would be created as soon as you perform clone on the local workstation as well. So that's the beauty of Git. So now let's try to understand what is Git workflow. This is not really complicated, right? Let's say you are a developer, you are ready to work on your code changes. So you would be performing Git clone. So when you perform Git clone, entire repository would be copied into your local machine, right? Your workstation. So it would create a local repository. And then let's say you are collaborating with other team members. If you wanted to download or sync up other developers code changes, you would be performing git pull command periodically, right? And then when you perform git pull, it is going to fetch the code, and plus it will also do auto merge. But let's say you want to download the code, but you don't want to merge in your local workspace, and then you can also perform git fetch command. Okay, that is a bit more safer option, right? If you don't want to merge other developers code changes into a workspace, you can just do a git fetch. And then let's say you started making code changes, you're ready to commit your code changes, so you're going to perform git add after you made code changes. And then you can, let's say you're working on 5 or 6 files, right? And you want to commit only a few files, then you would be performing git add and then mention those file names. So whenever you perform git add, it is going to qualify those files for commit, by moving into a staging area, right? And then once you want to commit, you can go ahead and then perform git commit. So that would commit your code changes into a local repository first. Okay, so whenever you perform git commit, it doesn't go into remote repository. It always commits into a local repository. And then once you decided to push into a remote repository, you can go ahead and then perform git push command. Okay, and then in case of reverting the code changes, you can also perform git checkout command. All right, and then there is also git diff command. Let's say you are making code changes, you wanted to see what is already there. You can also perform git diff command in order to see the code changes. All right, so yeah, so this is a typical Git workflow, guys. So now let's try to understand most used Git commands, isn't it? I know we have a lot of commands. We would be learning as we move forward as well. Just to highlight few commands in the slide, like git clone. So git clone is mainly for cloning from remote repository into local repository, right? And then git pull is for syncing up your local repository with other developers changes. And then just to name a few, git add, so you can qualify your files for commit. So when you perform git add, it is going to move the files into a staging area, which we saw in the previous diagram. And then git commit for committing into local repo. Git push is for committing from local into a remote repository. And then of course, git branch is going to create a new branch. Git merge is from merging from one branch into another branch. And then git revert is for reverting your bad commit. If you have anything, if you want to revert back your code changes, you can also do that as well. All right, guys, so that is pretty much. So now let's go ahead and then get started on our hands-on lab exercise. So this is what we are trying to do, right? We are going to set up a Java project into GitHub. So if you look at this diagram, we are going to use our Jenkins EC2 instance, and we are going to securely integrate with GitHub. How are we going to do that? We are going to create SSH keys and then upload the public key into GitHub. And we are going to, download the repository, and then we're going to start making code changes, right? So that's what we are going to do. So for that, obviously, if you look at the prerequisite, yes, we need to have GitHub account created. So I already have GitHub. So this is my GitHub repository, guys. And this is our Jenkins EC2 instance running in AWS Cloud. So that's our Jenkins EC2 instance running in AWS Cloud. And then, yes, we are going to use Git bash to connect, right? So yeah, so I'm going to use my item. So perfect. I think we have all the prerequisite configured. So now let's go ahead and then create a repository Obviously, right, we need to create a repository in GitHub. So let me go ahead and then create a repository. So click on this plus sign and then click on new, and then go ahead and then provide a repository name. So let's name this as my Java web app repo. Perfect. And I'm going to make this as a private. So that is important. And then if you want to create a README file with it, let's go ahead and then click on add a README file and then create repository. Perfect, right? So we have created our initial repository. Obviously, this has only the README file. So now let's go ahead and then again, if you look at this diagram, everything is clearly documented, right? So we have already repository created, and then we have to create SSH keys and then upload the public key into GitHub, right? So now let's go back to our Jenkins EC2 instance. So let's go ahead and then create SSH keys over here. So how are you going to create? You're going to perform SSH keygen command. So this should create SSH keys. Enter. So it is asking me, to enter a file name where it can be saved. So I'm okay with this default, whatever is coming up with the name. Enter. And then it is asking for a fast phrase to enter. I don't need anything. Enter. There you go. So now, as you can see here, SSH keys have been created over here, right? So let's go inside .ssh folder. Let me clear the screen again, type ls-al. So now you can see here, right? So what this would do is when you perform SSH keygen command, that would create a public key like this, and then it would also create a private key. So private key always stays within the same machine. Never ever share your private key with anyone, but we just need to upload the public key only, right? So how do you do that? You have to perform cat command. So all we have to do is, copy the public key only. So make sure you copy the entire content of the file. And then let's go to GitHub and click on your avatar and then click on settings and then go to SSH and GPG keys, new SSH key. You're going to put that over here and then click on add. So I have enabled multi-factor authentication for my GitHub account. So I'm going to go ahead and then enter the code. Perfect. So our public keys have been uploaded into GitHub. So let's get back into the diagram. So now we can go ahead and then clone the repository, right? So let me get back to the SSH terminal. Come out of the folder, clear the screen. So we can go ahead and then download the code, right? So this is the repo what we just created, right? So click on code and under clone, make sure you select the URL under SSH. I would never ever recommend by cloning this way. Okay, so when you clone using HTTPS URL, whenever you push your code changes, it is going to ask you to enter username and password. So always use SSH. So copy the URL, go back to your terminal and then perform git clone and then paste the URL, enter. Now just type yes. Awesome. You all see here. So now this has downloaded the entire repository, right, on this Jenkins EC2 instance. Again, I'm just using Jenkins EC2 instance as good as like my local machine. So you can also use your local machine if you have already, Java or Maven already installed, because you're going to create a, your Java project and so on, right? So I'm kind of using Jenkins EC2 instance, but again, you can use any machine to create a Java project. All right, perfect. So now let's go inside the repository and then type ls-al. So you can clearly see here, README file is created, right? Again, you can also see here as well. So it has only the README file. And then if you also see how many commits are there, obviously. So when we created a repository, it created, this particular commit. Okay. All right, perfect. And then let's go ahead and then create a Java project using Maven. So let's get back into our OneNote here. So we are going to create a Java project. So, but again, right, there are so many ways you can create a Java project, but I'm going to use a Maven, right? So Maven is one of the popular build tool mainly for building Java-based application. And using Maven, you can also create a Java project as well. So how would you do that? You can also perform Google search as well. So when you do a Google search, let's go to this particular website, and there you go. You can see here, right? So this is the Maven command, right? So you can, give your group ID and then artifact ID, which is nothing but, the application name, and then it has some, archetype, right? So you can choose what type of application that you wanted to, right? And then when you do it, most importantly, it is going to create this directory structure. So that's the beauty of this, particular Maven command. And then it would also have this, pom.xml file as well. This will also go ahead and then create pom.xml file. So pom.xml file is nothing but it's a Maven configuration file, which would have all the dependencies and so on. So whenever you use Maven to do a build, it is going to refer this particular file, right? So that's all it is. All right. So let's get back to our notes. So I have already simplified our command. As you can see here, I wanted to create web app, and then I wanted to create, my web app name would be this. But again, it's up to you. If you wanted to give a different name, you can also do that as well. But before that, if you guys remember, we have already installed Maven, right? So Maven needs to be installed. All right. So as you can see right now, it is in the process of creating the Java project. Wonderful. So now the Java project has been created and you can clearly see here. So now let's try to view the directory structure of this particular app. So let me go ahead and then type tree command. So tree is not there. Let's go ahead and then install this utility. So tree is a utility to view a directory structure of a folder. There you go. Can you all see here? So using this Maven command, we were able to create, this particular web app along with this pom.xml file, which is nothing but it's a Maven configuration file, right? And then all these folders and then a couple of files. All right. So now let's go ahead and then perform git status command. So when you perform git status command, it's going to show you untracked files. So it shows that my web app in red color, right? Because we have not done anything, right? We just made code changes, but we have not, staged any files for commit, correct? So in order to do that, we are going to perform git add my web app. So now you go ahead and then perform git status. There you go. You see here. So red become green. So now we can go ahead and then, commit these files, right? They're all ready to be committed, right? So let's go ahead and then say git commit -m, and then you can say setup Java web app. So there you go. So whenever you perform this command, since we just set up this repository and then clone, and we are actually making code changes for the very first time against this repository, so we need to go ahead and then provide we have to go ahead and then set up a username and then email, right? So let's go ahead and then provide that. So you need to provide your email address. So I'm going to say devops.coaching@gmail.com. And then we'll also go ahead and then provide our username. I'm going to say DevOps Coach. Enter. Fantastic. Clear screen. So now let's go ahead and then perform git commit. There you go. So our files have been committed into a local repository. So obviously, right, this is only in the local repository. So you can also perform git log command. So when you perform git log command, it's going to show how many commits have been made in the local repository, right? So we see 2. Now let me go back to GitHub, click on refresh. So why we are not seeing anything, right? Why we see only 1 commit? Because we committed only in the local repository. If you remember this Git workflow, you see here, so we are committing into a local repository first. So now if you want to upload from local into remote, you have to perform git push command, isn't it? Let's go ahead and then perform git push command. Fantastic. Now everything has been pushed from local repository into remote repository. Let's go ahead and then verify in GitHub. Wow. You all see here, and you can also click on the commit history to see, the message as well, right? So this is how, guys, you can go ahead and then set up a Java project in GitHub. I hope this lecture was useful. I'm looking forward to see you guys in the next lecture. Thank you so much.